Hello, my name is Sergey. I'm going to show you my final project. The topic is AWS Rekognition Face Detection Service for Retail. So the problem I'm trying to solve is the following. So there are thousands of small, medium-sized businesses and business owners have certain issues with understanding their customers. Comparing to online world where you can get granular data about your customers, their age, demographics, and preferences, there is a very limited number of options when it comes to physical space, especially when you're a small business owners. Think of small coffee shops, small retail stores. Those business owners would be happy to get more information about their user base and their demographics. So this is like a grand vision for the application, how it can look in the future. So basically the solution would capture customer face and then transfer to the cloud for further analytics. Then it would store information about that particular user, maybe anonymized, and then it can derive some interesting insights that would enable business owners or cashier offer particular product to sell or cross-sell an item during a shopping transaction. And then all the data can be shown in a dashboard like BI or analytics tool for a business owner on a weekly or monthly basis. So yeah, we've seen similar solutions in some of the movies, like this Minority Report. You may remember how Tom Cruise went in Gap store and virtual Jennifer Aniston offered him some product based on his look and previous purchases. So this is a high-level solution architecture for the application. It consists of three layers. There is a front-end layer, there is a back-end application logic layer, and this visualization. The front-end layer, what it does, it captures real-world image through a mobile phone. In our case, it's an iOS device, it's iPhone. Then it transmits the photo to AWS through AWS Mobile Hub. It places image photo to the S3 bucket. It's a simple storage object storage system. That object placed in the bucket triggers Lambda serverless function written in Python that asks Rekognition to access the photo in S3 and analyze it. So after Rekognition analyzes it, it returns face features, face analytics data to Lambda, and then Lambda writes all the data to DynamoDB NoSQL database server, and we have all the data stored in a nice-looking DynamoDB table. From that table, we can easily analyze the data, do visualization through, for example, built-in service Amazon QuickSight or Python Matplotlib libraries, or some other third-party tools. So these are the technologies that I used during this project. So for front-end, for the demo mobile app, I used AWS Mobile Hub, Xcode, and you see this is how it looked compiled in Xcode, and this is the real application that I installed on my iPhone. So backend utilizes multiple AWS services like Amazon S3, AWS Lambda, Rekognition, and Amazon DynamoDB, and visualization made through Amazon QuickSight and Matplotlib. So Amazon Rekognition, you probably heard about this. This is a managed service that works through API. You can detect different objects, faces, face features on images and videos. So it's a pretty easy service to work with. So it's fully managed. You don't need provision any server infrastructure, and it's pretty local. So you can analyze 1,000 images for $1. If you analyze more, it probably can get even cheaper for you. So when we come to data that I used in my project, so the vision is to use real world data. So in production, app is supposed to analyze photos coming from surveillance camera or camera installed inside the store. So in my case, I have camera on the phone, so it can be streamed from the phone. But also to test the system, I used a separate data set. It's about 1,000 images. It's called Lookalike Face Database with more than 1,000 images. So let's try it out. Let's check out the mobile app first. That can upload a photo we capture from a phone, like in this case, to AWS. So we open up the application we created. This is it. We upload the photo, go to camera roll, select the photo. Okay, give it a name, JS John Stark dot JPG. Okay, done. And we see the file is being uploaded to AWS for image recognition. Okay, done. Now we're going to check. So we go to S3, refresh. Okay, we see the file, JS. Now let's go and see if we analyze the image. So this is my DynamoDB table. Okay, perfect. Yes, this is the file. JS JPG, average age 37, battered true, emotion, sad, and a bit confused. Okay, perfect. So that was the real test for photo uploaded from the phone. We can also test the application with the larger data set. So we're going to use it this lookalike face detection data set to analyze our face detection system. So this is my S3 bucket. So this is my S3 bucket. I'm going. So we don't see the file with Jon Snow because that was a demo I pre-recorded before. So and I cleared the bucket after that. But we're going to upload new files that would trigger Lambda function and then trigger Amazon Rekognition to analyze the files. So I'm going to select the files. So we can, I don't know, let's say maybe like 30 images. Okay, so we upload them, see them, they're being uploaded. Okay. Okay, nice. We've got all of them. Now we go to DynamoDB and voila, we have 30 records. So 30 face images have been analyzed. So we can see different parameters here. We have average age, we have age bracket. So Amazon Rekognition provides only the bracket, so low and high estimation. So I added custom field, it's average. So it can also analyze emotions. So I selected only two emotions with the highest predicted accuracy. So this emotion 1, this is highest accuracy, and this is the probability from 0 to 100%. This is the second emotion. So we can also get some understanding about the face. So if the face has a person has a beard or not, if they wear eyeglasses, of course, gender, is it a male or female, mustache, is person smiling or not. So if there is a smile or not, so you can see prediction if there is a smile, and we see confidence. So it can be like confidence either for no smile or for a smile. And also we can get information if there are sunglasses, yes or no. So yeah, all of them, they don't wear sunglasses. And I also have a timestamp. So yeah, so that's basically it. So when we look back at the solution architecture, we can see, so in the first example, we uploaded a photo from a phone to S3 bucket. Again, a triggered Lambda function, asked Amazon Rekognition to access the photo that we just uploaded. Then Rekognition analyzed the photo, returned data points that were recorded to DynamoDB. And so basically, after we uploaded the photo, all those steps were automated. So it took like less than seconds to do that and write it to the table. In our second example, what we did, so we started from here. So we just uploaded objects from a local computer, local files to the bucket. Again, that event of uploading a new object, creating a new object into the bucket, it triggered the same loop, and we got all those parameters written to DynamoDB. So basically, this kind of application can work with different data sets. So the only prerequisite is that all those files should be added to that S3 bucket, S3 folder, and that will trigger that Lambda function. So once you've done that, you can analyze the data in the QuickSight or Matplotlib. So I can show some examples. For example, yeah. For example, I analyzed this similar file. So first of all, I can download CSCI from DynamoDB to analyze it. So here I create first a data frame in Python from that CSV. So simplify how I can work with that. And then I use Matplotlib libraries to analyze the data. So I can see, like, from a number of pictures, what is like if a person smiling or not, and what is the confidence for that. So this is one of the examples. More handy is to use Amazon QuickSight to analyze the emotion, so we can check it out. So here's the table that we created. So we can select our items, can export to CSV, will be file photos.csv. Then we go to analytics, to QuickSight. Okay, manage data, new data set, upload a file, downloads. Okay, visualize. Okay, we've got it. So we can, for example, add age and gender. Yeah, so average. Yeah, so we can see here, like in our data set, we have more. So average age of male is 44, and average age of female is 35, and we can do a bunch of different analytics. We can slice and dice this data in QuickSight or any other third-party analytic tool. So going back to the presentation. So the installation is straightforward. Basically, I guided you through the architecture already. So the lessons I learned. So although API can be easy to work with, at least like the appearance is very attractive. Learning how to interact with the API, how to use it, how to call commands can take some time. So there is a learning curve involved. Also, like many AWS services, like all the services that we use, DynamoDB, Lambda, S3, or Rekognition, they have auto-scaling capabilities. So they're serverless, you don't need to manage infrastructure for them. But they're still located in physical data center. So and they can only support different regions. Some of the services support only certain regions. So you need to plan your architecture with that in mind. So some of the advantages of the architecture that I selected is a serverless architecture. So no resource provisioning, management, updates, or patches. So there is an auto scaling up to millions of users and transactions instantly. So even like that pretty simple application can support millions of transactions, so it without any extra provisioning. The cost consideration is a different topic. So some of the cons. So if somebody decides to use this app, so that new data will be collected by AWS and will in long term benefit AWS because they're going to use that data. So their deep learning model will be improved. So larger companies may consider developing their own application to benefit from data, learn their model, and keep the data, those insights to themselves. And DynamoDB is a great managed service, but it lacks convenience of traditional SQL databases. It's more difficult to query and visualize it. So the next steps that I'm thinking of is just to automate and make better visualization dashboards, make fully functional native mobile apps, image pre-processing at the mobile device, maybe like a CCTV camera, so compress image, resize it before sending to the cloud, and maybe automate face detection, photo capturing by camera. So not pressing the button, but device would understand what the face in the camera and make a photo itself. And also there might be index search for faces implementing Rekognition, and also recommendation engine if I'm going to use it for this customer side for helping business owners derive more value from their business. So again, thanks a lot for your time. Hope you like it.